And so we neglected the unpurged products of combustion. It adds a great deal of complexity and detracts from our being able to do the overall analysis. So now we need to balance the reaction equation for 80% excess error, 100% theoretical error for C12H26, assuming complete combustion. And I'll write down the combustion equation without going through each of the steps to get there. So we have C12H26 plus 1.8, so this is for the 80% excess, times 18.5 times O2 plus 3.76 N2 yields 12 CO2 plus 13 H2O plus 14.8 O2 plus 125.2 N2. What this is going to enable us to do is get the fuel-air ratio. So I'll need the fuel-air ratio to find the heat in. So when I do the heat in, remember we said Q in was RFA times H sub RP, and that's where this is going. So that's where this strategy is. So RAF is equal to 158 moles of air. Remember that's 4.76 times 28.97 divided by 1 mole of fuel, and this is 170.3 is the molecular weight of the fuel. So RAF is 26.92 kilograms air per kilogram fuel. And if we take the reciprocal, RFA is equal to 0.03709 kilograms fuel per kilogram air. And so we will be using this information, later on. Now let's go through the cycle. So now we have to go through the cycle and find all the cycle state points and all that sort of stuff. So let's do that. I'm going to erase this. I have the important piece of information that I needed. So if we draw our PV diagram for this, just it helps us stay on track. One, two. So I see where we are. So I have the PV diagram. Now we're going to go through process by process. We know the process 1 to 2. PV to the K. So T2 is equal to T1 times V1 over V2 to the K minus 1 is equal to 310 times 11.4 to the 0.4, where I have the T2 is equal to 820.5 degrees K, and that P2 is equal to P1 times V1 over V2 to the K. His P1 is 100. Oh, and we know this was 3,000. We were given this. Thank you. That was silly. And now we're going to look at the work from 1 to 2. So I can look at the work from 1 to 2. So Q12, Q is equal to delta U plus W. And from 1 to 2, Q is 0. So W is equal to U2 minus U1 is equal to C sub B T2 minus T1. So W is equal to 0.7176 times T2, 820.5, minus T1, 310. And so we get that W12 is equal to 366.3 kilojoules per kilogram. Now the process 2 to 3 is constant pressure combustion. So it starts off as air, I'm adding fuel, and I end up with products. So I have HA2 plus RFA H sub RP. So this is the energy that's being added. The energy at state 2 with the air, energy being added by the fuel is going to equal to the energy of the products at state 3. It is 1 plus RFA H sub 3P, or P. Anyway, and so then we're going to substitute in the specific heats for the various things. So this is C sub PA T2 plus RFA H sub RP is equal to 1 plus RFA times C sub P of the products T3. So I have C sub P of the products T3. And now I have to substitute in all the numbers and solve for that stuff. So that's what we'll do next. So 1.0047 C sub P of the air times 820.5 plus RFA, which is 0.03709 times H sub RP of dodecane 44,102. Table C3 is equal to 1 plus RFA, 1.03709, 1 plus RFA times the C sub P of the products, 1.048 times T3. So I'm able to solve for T3, and T3 is equal to 2263.5 degrees K. P3 is equal to P2 is equal to 3000 kPa. And now what I can do is solve for T3, right? For V3. So for P equals C, P over specific volume is equal to a constant. And remember, I always use this PV equals RT. So I never remember the Charles law of variations, but if pressure is constant, then T over V is a constant. So V3 is equal to V2 times T3 over T2 is equal to 0.301236041 times 2263.5 over 820.5. And I have the V3 is 0.201666 cubic meters, and V4 is equal to V1, and I know that's equal to 0.006887 cubic meters. And now what we have to do, we're finding all these things. I need to also now look at the process from 3 to 4. So we'll look at the process from 3 to 4. I know V3, V4. Now I can use the isentropic relationships to find T4. So I'll look at the process from 3 to 4. PV to the K is a constant. And so I can use the isentropic relationships that T4 is equal to T3 times V3 over V4 to the K minus 1. So we have 3263.5 times the volumes 0.001666 divided by 0.006887 to the 0.33. So in this case with the products, we're using K of 1.383 rather than 1.4. And we have that T4 is equal to 1314.5 degrees K. And what I'd like to do is find the work from 3 to 4. So we'll find the work from 3 to 4. And so we have that process 3 to 4. W is equal to, or Q is equal to delta U plus W. Q is 0, so W is equal to delta U. So I have that. So the W from 3 to 4 is equal to, now there's 1 plus RFA is the amount of 1 plus RFA, because I have air plus fuel, times C sub B of the products times T3 minus T4. And if I substitute in here, we have 1.03709 times C sub B of the products, 0.7537 times the delta T, 3263.5 minus 820.5. It keeps going on. And so then we get W34. I'm going to finish this up before I have to erase. W34 is equal to 741.7. And so what we're doing in terms of strategy is we're finding the work here of compression. Now we'll find the work here and the work here, add them together and get the net work.